December 5th, 2013. Guys, we're looking at the images from stereo ahead. You can see the solar activity starting to pick back up. And what we're getting is that in the 27-day rotation of these sunspots, that 1890 group is turning back around. You can see the movie here from A, and I'll show you also from B. And it's a wide blast because when they come out of the same side of both cameras, that's telling you you've got about 180 degrees that you're looking at. And it's kind of strange to see a flare come out the same side of when you're looking at stereo behind and stereo A because they're on opposite sides of the sun. Strong flares. Look, coming in on the left of the sun, that's that 1890 group that on November 5th, if you remember, gave us an X3. Now, the sunspot that's that area in the middle, you see the sunspot growing. Now, something that's not showing up on a lot of the instruments is at the top of this. I have watched for about 3 days this large filament come across the face of the sun. If you watch it, you can see it release a huge CME out to the right. Now, this is the sunspot summary. You can see we don't have anything that's triple configurated yet. But again, over to the left, it says a pair of active regions, including old sunspot 1893, are rotating around. Now, it was 1890 of this group. Remember, look at the date, November 5th, 1 month. We got this X-class flare. Same group of sunspots, and they're coming back around. And also notice the sunspots are in the southern half of the sun, and they say that's because of the movement of the sun trying to reverse its poles. That will happen before that point. Here's the filament release. 109 Earths to cover the equator of the sun to go across there to give you a size comparison. That little sunspot that's Earth facing is growing right there. But what I'm more concerned about the 1890 group coming around, but I do want to show you the activity in this thing. Everything's active on the sun. We're actually getting some pretty good flares from this, and I'll show you on a different camera. Give you your brighter images as far as your X flares. If you go to this teal camera on the SDO, you can see there. Now, again, that's Earth facing. On the left will be Earth facing. So if you divide that rotation up by 27 days, guys, every 7 days you can see that you're going to have quite a bit of movement across the Earth-facing side of the sun. And we'll take a look at it in the HMI gray. And you can see, guys, coming in on the left there, that's going to be a large area that we'll be dealing with the 1890 group. Now, this is a close-up of this small sunspot that we're watching that is Earth facing now. You can see it grow in this camera. It's just a lot of activity there. It's not a large flare compared to some we've seen. But again, I think our problem's coming in on the left. We're going to have to watch that this week. The dust ball faded away. You see how it appears to fade away? Guys, it's moving 2 million miles away from this camera a day. Have you ever shot a rifle and tried to project ahead of that or to look at an object moving away from you? Imagine it doing it at 2 million miles a day. That's what this is. This is a huge ball of debris. There's rocks in there bigger than this. This is NASA's radar imaging of 2012 DEA-14. That's what you're seeing. That's the only way we're going to be able to see these large rocks in ISON now. They are dark. When do you see a meteor shower? When it hits the atmosphere. Remember, as we were watching 2012 DEA-14, NASA pulled the classic bait and switch. They knew that this meteor was coming in over Russia, but they had all eyes the other way. That is their mode of operation. Check this out. Guys, if you examine this closely on some of the other images, a missile hits that meteorite, skips back off, and knocks it into sections. That second explosion was a missile strike from the rear. I don't have those images, but they are available online with real close examination. You can see it, guys. But my point is here, with everyone saying, and if they're telling you this is a small dust ball, they're lying to you. This is what it looked like. This is just from the shock waves. This building was not struck by a rock. Okay. Now, you see the orbits. The inner blue ring is 2012 DA14. It's coming around all the time. But they were watching this outer blue ring. This thing didn't come in there and sneak up on them like that. It came in while they had their attention away from it. Now, as you look at these comparisons of different size rocks, the Barringer crater on the left that hit in the desert in Arizona, your Russian meteorite there, the Tunguski Comet fragment, look at that, 330 feet, 100 meters, right? The rocks inside ISON make these look like sand pebbles. And don't forget, guys, at 11 a.m. this morning, Central Time, the Paul Begley show is going to be very interesting. He's going to let me call in. We're going to talk about some of this stuff.